Alright, second part of this chapter, motion. Okay, so types of motion. So first type is translatory motion. So translatory motion, a body is said to have a translatory motion if every point on the body moves through the same distance and same interval of time. Alright. So for example, this girl, she is riding a bicycle. In that case, all the parts are moving at the same distance at the same interval of time. Okay. So the back tire was earlier over here, so now it has reached over here. The front tires were over here, then they have reached over here. So the distance has remained the same. Okay, so all the points. Okay, the girl itself is sitting on this seat. Okay, she continues to sit even over here and even over here. The distance will remain the same as this distance, and this distance will also remain the same. So a body is said to have a translatory motion if every point on the moving body moves through the same distance in same interval of time. So every point on the body are moving with the same distance. They are traveling same distance in same interval of time. That is called as a translatory motion. The other example is a ball been dropped. So all the points on the ball, okay, this distance will remain the same. It won't change. So they will travel the same distance as it is going down. So any straight line motion is called as a translatory motion. Okay, now translatory motion are of two types. Okay, one is rectilinear, that is a straight line motion. Okay, linear means line, straight line, and curvilinear, that is it forms a curve. So let us see the example. Rectilinear, a car, okay, moving on a straight road. Okay, that is an example of a rectilinear motion. The other example would be a ball that has been dropped. Okay, so if you are dropping the ball, in that case it will follow a straight path, so it will be a rectilinear motion. Right. A train traveling on a track, on a straight track, when a train has been traveling, that is a rectilinear motion. So these are the examples of rectilinear motion. Let us see curvilinear motion. Okay, athletes running on a curved track. Okay, you see a curve over here. Okay, on that track they are running, so it's a curvilinear motion. Okay, a roller coaster ride, that is a curve, so that will be a curvilinear motion. Okay, a girl throwing a ball. Okay, a basketball has been thrown. Now it forms a trajectory. Okay, this would be a curvilinear motion. A car moving on a curved road, that would be an example of curvilinear motion. Okay, a plane performing acrobatics. Okay, so it is forming a curve, so that would be a curvilinear motion. Now let us see rotatory motion and circular motion together. All right. So what is rotatory motion? When a body moves about a fixed point or a fixed axis. So it has an axis. On its own axis, when a body moves, the body is said to have a rotatory motion. Okay, and what is circular motion? When a body moves in a circular path, so it is going around something, that is when we say it is revolving or it is performing a circular motion. So example of rotatory motion, earth moving on its axis. So this is the axis of the earth, and earth goes round its axis. Okay, so it completes one rotation, that is one day. Okay, and the same earth, it goes round the sun. Okay, so it is performing a circular motion. Over here, the it is going around the sun. Okay, it is going around the sun. Over here it is going around itself, so it is moving on its axis. So if it is something is moving on its axis, we call it as rotatory motion, and if it is going around something, we call it as circular motion. All right, the other example would be this thing. Okay, so it has its axis. On its axis it moves, it performs, it goes around, rotational motion it performs, so it is called as a rotatory motion. This will be an example. The other example would be a top. So through its body, you see this is the axis of rotation of the top. Okay, and it is spinning on it on its own axis, so this is a rotatory motion. Now let's see the example for circular motion. A car going on a circular road. Okay, so this is the center of it, and the car is moving in a circular path, so that is a circular motion. A satellite, okay, going around the earth, that is a circular motion, so it is going around something, it has nothing to do with its axis. Okay, so what is the basic difference between a circular motion and rotatory motion. In rotatory motion, the axis of rotation passes from the point in the body itself. So from inside the body, you form the axis of it. Whereas in circular motion, the axis of revolution passes through the point outside the body. So it is outside the body. So this is the body. Satellite is the body. It is moving in a circular path, but the center is outside its body. It is not inside the body. Okay, one more thing, the difference between translatory motion and rotatory motion is, in translatory motion, all the points were traveling equal distance at equal interval of time. Over here, you see the point A, B, C, and D. Okay, A will travel a less distance as compared to point B, or point D will travel a larger distance. So over here, every point will not travel the same distance. All right. Okay, let's move on. Okay, oscillatory motion and vibratory motion. So oscillatory motion, to and fro motion of a body from its rest position is called as oscillatory motion. So from its rest position, when it starts moving, it performs to and fro motion. It is called as oscillatory motion. Vibratory motion, to and fro motion of a part of a body keeping its rest part fixed is called as vibratory motion. So we'll understand with examples. The difference between a vibratory motion and is that shape and the size of the body changes. So in vibratory motion, the shape and the size changes. In oscillatory motion, it doesn't happen. So let's see the examples for oscillatory motion. Okay, girl on a swing. Okay, so there's no change in her body. Okay, she's performing a to and fro motion. So she's swinging in both the sides, going at one side, to and fro motion. So this is an oscillatory motion. The other example would be a pendulum swinging. That would be an example of oscillatory motion. Okay, here also it is nothing is happening to the bob of the pendulum. Okay. Now, the example for vibratory motion would be strumming of a guitar. In that case, the string will vibrate. Okay, or you vibrate any other things. In that case, it will vibrate. Okay, here I have a better picture. You see the shape and the size of this string has changed. Okay, so during that period of time when it is vibrating, you can see the to and fro motion of it. Okay, so when it is vibrating, okay, its shape and size changes for that particular period of time. So this is an example of vibratory motion. Now let's see periodic and non-periodic motion. So periodic motion is a motion which repeats itself at regular interval. Okay, and non-periodic motion is a motion which does not repeat itself after a regular interval. For example, a pendulum will perform a to and fro motion. Okay, the motion which repeats itself after regular interval will called as a periodic motion. Okay. And non-periodic motion. Okay, so examples of periodic motion is heartbeat. Okay, that is again an example of periodic motion. A very nice example would be the Earth. Earth goes around itself, so it performs a rotation motion in 24 hours. So it is fixed every 24 hours. It's complete one rotation. Hence there is one day. And in 365 and a quarter day, it performs one circular motion. It goes around the sun. Okay, or it revolves around the sun in 365 and a quarter day. That is, so it is a periodic motion. It takes same time. Okay, it doesn't changes. Now let us see the example for non-periodic motion. For example, particles of gas. Okay, the particle of gas, they perform random motion. They move in any direction, and the motion changes once they hit the wall of the container, or they collide among themselves, and the path changes. So there is no fixed pattern how they will move. So they move in any direction and any which ways. All right. The other practical example would be a footballer running on a field. So at his position, if he is moving, so wherever the ball comes at his position, he will move accordingly. Okay, he won't be performing a march pass, or he won't be moving at a fixed way how he has to go. So it depends on the ball. Where the ball drops, he'll go and collect it. Okay, so that is a non-periodic motion. Mixed motion. So a body can have more than one type of motion simultaneously. Such motion is called as mixed motion. So for example, this screw over here, okay, it is performing a rotatory motion. Okay, once the drill is trying to rotate it, at the same time it also performs a translatory motion, or it goes inside this wood. So it is performing a translatory motion. So it is performing both the motions, hence it is called as a mixed motion. The other example would be a saw. So saw while cutting, it is performing an oscillatory motion. It's a to and fro motion, coming up, going down, to and fro motion. At the same time, it is moving in this direction also. That is a translatory motion or a straight line motion. Okay, it is going in a straight line. The best example would be Earth. Earth performs rotatory motion. Okay, so we have a day. Okay, and it performs a circular motion. Hence, we have a year. So it rotates around its axis. Okay, so in 24 hours, and it completes one complete revolution around the sun, or it revolves around the sun in 365 and a quarter day. All right, that's it. Thank you so much. Bye.